So we went ahead for pilot production to the best manufacturers. Then we ordered stainless steel from the market. You saw the stainless steel which we used for prototypes. They were like undulated. They look like hand beaten. But in a pilot production, I need to have very, very high quality surfaces. So we went to Jindal Stainless Steel, and they gave us one of their best, grades of stainless steel, which is called Scotch Bright Finish. So that the headlamps of the car, when they hit on that stainless steel, they don't reflect back. So, and then they also took us to their manufacturing unit, which is called the Jindal Architecture, where we produced the components using CNC punching. What's the advantage of computer numerical punching of a sheet before you fold it?
Accurate corners and folds.
Accurate corners and folds, saving of material, nesting of parts. I don't lose any sheet. I just, punch all along and I take all the parts out. Look at the, sections which are coming at the end. Every small part I punch and use for some purpose. And I nest my components so that I use all the sheet very effectively, as well as the most important point is that it gives you very, very accurate parts and gives you very, very high quality. And now comes the laser cutting. In CNC, turret punch and cut the material. In laser, you cut using lasers. What are the difference between the two? Why do you need to use laser sometimes and the punch sometimes in a prototype? I'm doing a pilot production, right? I've got very less quantity. So how many punches will I have? If I have different diameters, if I want to cut a logo, I want to cut a postbox logo on stainless steel. So when you have prototypes, generally what you do, you use laser cutting because your volume is less. You can use laser to cut the material, and laser of course gives better edges. Laser also, gives you very, very intricate shapes. And then what is this beautiful machine here? This is computer numerical control bending. Stainless steel material is a very, very tough material. Here we have all the inputs coming from our mechanical engineering professors, our professors from manufacturing. So we have all the good features we built in. Large envelopes can be posted. You have a posting rest. You can rest your hand to post the letters. And then you have these, design where you have no welding outside. Look at all the radiuses. Now, are you able to see the radius? The edge, you can see those shines which are because of the multiple 22 strokes of the round radius. And then you fold inside and weld inside. When you bend and you weld on it, it makes lot of stress undulation. So your sheet becomes very undulated. Then we have a tough composite top. What are composites?
Mixture of two materials.
Mixture of two materials in this case.
Plastic.
Plastic and glass. So glass fiber reinforced plastic is very, very strong. And you can see they call the fiber reinforced plastics, FRP. You heard about FRP? They also using FRP, they make sculptures.
Most FRP structures have that, you can see the pattern of the fiber.
You can see the pattern of the fiber, but you have more resin on the top. You won't see the pattern. And you paint it, this is painted.
But otherwise it was visible.
Otherwise, it's a pure choice. You want to show the fiber on the top, you put rest resin. You have 2 layers of resin and then you put the fiber. You won't see the fiber. It totally depends upon how you process your fiber reinforced plastics. Why am I using fiber reinforced plastics over here?
Cheap but strong.
No. Engineering plastics needs tooling, injection molding. And the injection molding dies will cost me more than the order quantity. All the 20 boxes put together, the cost of that I won't get a die to injection mold a engineering plastic. What's the advantage? It's actually as strong as engineering plastics. So we're getting the advantage of the strength, but low volume production using this. But the component cost, per cost of a component is costlier than the engineering plastic because engineering plastic large volumes, then amortization of cost, whereas in this case you're making less number, so it's more expensive. Then we have this very interesting feature. So we put a sliding panel inside all the time. So he doesn't need to take it out. He quickly slides the time and he can go, and you can see the very prominent pin number and the location address. So this is a feature built into the door, and the door is very strong in stainless steel. And then we had this contemporary look because of the radius. It looked very contemporary, and because of the smart top, it had a look which was very prominent, so it was very easily visible from everywhere. And we had these large surfaces where we could advertise. And then we have all the features built into this. The door is also locking very tight, so you have no insects going inside. Then we have the foundation bolts put. See the reverse post box, and you can see the foundation bolts. So all the bolts are like from inside, so nobody can uproot the box by using spanners.